Hey stranger who just so happened to click on this video, stop scrolling down and think about this for a second. How many states of matter do you know about? 3, maybe 4 for some of you who have reached your higher studies or are just curious learners. But did you know there's actually a 5th state of matter called BOSE-EINSTEIN condensate? With that being said, welcome to BOSE-EINSTEIN condensate for dummies. First of all, you need to understand the term bosons. It's very complicated, and so in our context, you can simply think of them as atoms of elements having the sum of their protons, neutrons, and electrons as an even number, such as rubidium. A boson gas is cooled to a temperature extremely close to 0 Kelvin or minus 273.15 degrees Celsius, otherwise known as absolute zero. Just to give you an idea, when it was made in 2018 in an experiment at a space station, the gas was cooled to 10 millionths of a degree above 0 Kelvin. The density must be really low to avoid the particles colliding together, causing a change in state. Now, how do we cool them? We cool them using lasers. In fact, 6 lasers from all 6 sides of the atom. Yes, lasers. This is because they emit photons, light particles, which are absorbed and then re-emitted by the atom. This drains the atom of its kinetic energy, sort of like repeatedly throwing and catching a ball. Eventually, your arm will tire out. It will have no more energy. Same is the case here, but instead of just one part of the body, it's the whole body itself. Now the kinetic energy falls to almost zero, and the same can be said about the temperature because, well, what is temperature? It's simply a measurement of the average kinetic energy of particles in an object. Eventually, all the bosons fall in the same minimal energy level. This is just a simple way of saying they are now in the same quantum state and have become virtually indistinguishable. Think of it like this. You and your friend throw a ball. Each will throw it with different energy, but eventually your arms will tire out so much that you both will throw it at the minimum possible energy. In quantum physics, matter exhibits properties of both particles and waves, otherwise known as particle-wave duality. Therefore, the same quantum state means that all the particles exhibit the same wave. This allows the waves to overlap, forming the wave of a much larger quantum object and a cluster of particles that are called a superatom. And this, my friends, is Bose-Einstein condensate. Think of the thickness of a single sheet of paper. It's almost negligible. Stack multiple papers on top of each other and you get the thickness of this tray. But what's worth noting is that the stack of paper can be bent just like a normal sheet of paper, although you need more energy. Hence the term superatom is used. Now, why does this concern you? This concerns you because Bose-Einstein condensate is used to make optical lattices and to make precise measurements, but the greater use is in quantum computing. Yes, Bose-Einstein condensate will be used in the development of quantum computing, which will eliminate the boundaries on physical computers and be faster, safer, and much more privacy-oriented.